It's time to talk about pulleys with the masses. In Newton's laws of motion, we have seen pulleys, systems, how the masses move, and the advantages of pulleys. But what happens when the pulleys themselves are non-ideal and they have mass? And we're going to see the most important equation which relates torque and moment of inertia. And also we'll end the lecture with rotational kinetic energy. All of this with your favorite capto, Shreyas, going live. Hi Suchi, Gokulnath, Ishpreet, hello Rasmi, Gokulnath, welcome Yash, welcome aboard everyone. For those of you who do not know me, well, I am Shreyas, I am the capto of this channel, and I am teaching for a very long time, and I love teaching and I enjoy teaching. I love physics. I almost got like full marks when I wrote my JEE, and this passion for physics and the love for teaching is what brought me here, and I am here on YouTube to spread this joy of learning to all the nooks and corners of this world. So let's get started. And we Enthuse is a very special dedicated channel for all the JEE aspirants in English medium. So if you haven't liked and subscribed, then please do that right now, because it motivates and boosts us a lot. So having said that, let me also quickly tell you, in case you have some backlogs, in case you want a mentor, and in case you want some help in completing the portions, and you want some assessments, tests and assignments after every chapter, and you want a dedicated plan, even now, even with your backlogs, there are programs running right now which are going to start this week for your 11th standard. There are crash courses kind of things, there are micro courses, there are revision sessions which are going on. So I feel you should definitely take help of that, including my micro courses which are available to complete your entire 11th standard syllabus. So don't be afraid to take help from Vedantu. So you don't have to travel anywhere. Just by sitting at home, you can learn and complete the 11th standard backlogs. And if you have already done the syllabus, then I feel you should master it and revise it through additional mock tests and revision series. So the best part is, right now there is a Children's Day offer which is going on, and you get 50% flat off, and you can try it out for 15 days. So that's an EdFest. The offer will run only till tomorrow. So do not forget to join the Vedantu Pro right now, because the courses are for as low as 750 rupees per 15 days. Okay, so go ahead, join it, and I will be really happy to see all of you on the Vedantu Pro subscription. Hi Binav, hi Arish, hello Saja, Chandan, welcome Aarti, Roshni, Jinan, hello, good evening everyone. Hi Dakshin. Oh, Dakshin, I'm right now not teaching any 11th standard English batch, but if you want to change your batch, definitely you can change your batch. And you can do one thing, Dakshin, you can just write a mail to vcare@vedantu.com. But if it's still not resolved, just do one thing, send me a screenshot and tag me on Instagram. I'll definitely look into it. All right, bacha? Okay. So can I please take a session on instantaneous axis of rotation? Dinesh, you just spoke my mind. In fact, I'm going to take that session as a part of some other topic combined with the other topic, because it is related to angular momentum and all of that as well. So we are going to do that, instantaneous axis of rotation. Don't worry about it. Okay, so we're going to do it. All right. Hi Umair, good evening. Thank you, your words mean a lot. Thank you so much. Okay, so Saja, very rightly said and very good observation. Usually my classes are at 7:30, but today I have some urgent work in the night, so that's the reason why I have to drop and pick up some family members. So that's the reason why I had to shift my class to 5:30. I didn't want to miss my class, so that's the reason why I'm keeping it at 5:30, which I felt most of you might be comfortable with. So let's get going. And Dakshin, if you want to see my micro courses, when you're a part of Vedantu Pro subscription, you just have to go to enroll more courses. You can search by my name or search my HC Verma, Aerodo, derivation, etc. You will get those courses. You just have to click enroll now. You don't have to pay anything extra. It's free of cost if you are a part of the Pro subscription. All right, chalo, let's get going. No Suchi, you cannot get derivation micro course without Pro subscription. Yep. Yes, no problem Yash, even if you are a NEET aspirant, you can still watch it. Okay, let's start quick recap. Remember, we have spoken about couple of things before this. So we have spoken about angular acceleration in circular motion. Just like you have acceleration, What does acceleration do? Rate of change of velocity is acceleration. What is angular acceleration? Rate of change of angular velocity. So if a particle is going in uniform circular motion, the angular acceleration, because there is no change in the speed, the angular acceleration is 0. But if the speed increases, then it has some angular acceleration. If the speed decreases, then it has angular deceleration or negative angular acceleration, you can say that. So unit was radian per second square. It is derivative of angular velocity or second derivative of angular position, and the symbol for that was alpha. Remember alpha. And remember, A was equal to alpha. Do you remember this? Yep. Do you remember this? I have told you tangential acceleration is r alpha, V is r omega. That's how you can remember it. V is r omega, A is r alpha. This A is the tangential acceleration. Alright. So this is one thing that you need to remember. Another recap that I want to do is moment of inertia. Just like in linear motion, you have mass. In rotational motion, what do you have? Rotational mass, which is rotational moment of inertia. So every body has a moment of inertia. It has a resistance to change its state of motion. So that is called as moment of inertia. The formula for that is sigma summation m1 r1 square plus m2 r2 square plus m3 r3 square. So each point mass into the distance from the axis square. Sum it up, you will get moment of inertia, and I have derived it for many objects. Let's see how many of you remember the moment of inertia for a disk. Come on, type it out in the chat box. What is the moment of inertia of a solid disk? Let me see how many of you remember it. Come on, my warriors. Dakshin, well, I think you have posted a comment. I'll tell you what you can do. I'll ping a link by which you can, find out my micro courses. There is very easy way of searching it. Okay, you just have to enter some keywords, you will get it. Okay, after the lecture ends, I'll probably reply to your comment if you post a comment after the video ends. Yes, mr square by 2, my warriors. Correcto. Beautiful. You guys remember it. Last thing, torque. Let's quickly recap torque. What is the analogous of force in rotation? It is the twisting force, the twisting cause, which is nothing but the torque. So torque causes the change in the state of rotation. When you twist and apply a torque, you start rotating or stop it from rotating. Okay, so that's what a torque does. It's a vector quantity. The direction is given by your right hand rule. So if you apply a torque like this, you use your right hand curled fingers and the thumb points in the direction of the torque, and it is always r cross f. Remember, I have given you this. R is the vector which points to the point where the force is applied from the axis. So r is the position vector of the force, f is the force itself, rf sine theta. That's what we have done. Okay, so having recapped all of this, so I think now it's fresh, just in case you had forgotten. And I hope you have also done the homework. I'm going to show all the stars who have done the homework in a bit, okay, towards the end of the class. So stay tuned out there. Exactly, yes, it is not the effect, it is the cause. Correct. So Bhimashri, torque is r cross f, that is the cause of rotation. R is not the radius, r is the distance from the axis or the position from the axis where you apply the force. So if, let's say, I'm trying to rotate something, I apply a force here. This is my r and this is my force, r cross f, which you have studied in vectors, vector product, that gives you torque. And in case you want a more detailed explanation, just watch my previous video, lecture number 2 on torque, exclusively dedicated to torque only. Detail mein I have explained. Okay, bacha? Okay, Bhimashri? Great. Yes, Abhinav, why not? That's why I'm here. You can be thorough through rotational mechanics just by watching my videos as well. Definitely. Okay. Now, what will torque do? See, I had told you that whenever there is a cause, it will have an effect. But the effect depends on something, and that something is basically inertia. For the same cause, you might not get the same effect because everything might have a different inertia. Like, for example, I tell all the students out here in the chat box, go study this chapter of rotational motion and come and solve all the exercises from H.C. Verma. Some of you might do a lot, some of you might not do at all, some of you might do less, some of you might do medium. So everybody has a different inertia. I am the cause. The effect of you guys doing the homework might depend on your inertia, your resistance to actually sit and study. So every body has a different inertia, hence it might have a different effect. I hope that makes sense. Now in linear motion, the cause was the force, the inertia was the mass, and the effect was acceleration. But in rotational motion, it's going to be slightly different, and we'll just come to that. I'll tell you, it's very, very easy. See, imagine that there is a body which is rotating, okay, which is rotating with some angular acceleration alpha, and there are many particles. Okay, each particle, let's say, has a mass like m1, has a distance from the axis like r1, has a tangential acceleration, let's say a1, and let's say it has a tangential force like f1. So a1t, f1t, these are the accelerations and forces tangentially on each particle. Similarly, there will be particle m2, m3, m4, etc. So mnth particle will have a distance of rn, and it will have an acceleration of an tangentially and a force of fn. So think of basically some object which is rotating. There are multiple particles, they are all going in circles, okay, around this axis, and each particle of this particular body, okay, it has some acceleration, it has some force, it has some mass. I hope you can understand it, and it has some distance from the axis. That's what it is. Is that clear, my bachalo? Is that understood what I have assumed? Now, if I ask you what is the net torque on that body, you will be like, it is nothing but torque on particle 1 plus torque on particle 2 plus the torque on the nth particle. Torque on particle 1 plus particle 2 plus particle 3, because that body is made of many particles. So each particle will experience torque. So the sum of all the torques will give you the total torque on the body. What is torque 1? It will be R1 into the force perpendicular to that, which is the tangential force. Remember, out of the two components, when you have this as the R, and if this is the force, this one will be the perpendicular force. That perpendicular force is what causes the torque. This component will never ever cause any kind of torque. Only the perpendicular force to R causes the rotation, rest do not cause any rotation. So R1 F1t plus R2 F2t and F2t, something like that, and last term will be Rn Fnt. Okay, now the next thing will be force. Force is mass into acceleration. So force is m1 into acceleration, and there will be many terms like that. Then the next substitution that I'm going to do is, it will be nothing but, what is acceleration? Acceleration tangentially is alpha r. I just gave you that formula. So instead of acceleration, just put alpha into r. R is nothing but r1. Okay, and I will have many terms like that. Now see what will happen. Alpha is same for all the particles. All the particles, no matter how far they are from the axis, they will have the same angle-wise acceleration. So alpha is common for all the particles, that is not different. So now what will happen is, if I take out alpha common, the first term will be m1, r1 into r1 will be r1 square. Similarly, next thing will have m2 into r2 square, and so on and so forth. Guys, what is this? What is this term inside this square bracket? Can you guys quickly guess and tell me? Can you guys think and tell me? So Hima Varshni, you can check out my previous video, it is all there. Yeah, just check out the video which I conducted on Sunday. That surprise is there. I've just conducted a session. So this is nothing but alpha, and this is nothing but moment of inertia. So this is nothing but the torque on the body. I think I got what I wanted exactly. So the final outcome is the net external torque acting on a body is moment of inertia into alpha. So this is your final equation, and that was also there in the thumbnail of today's class. So this is nothing but your cause, and this alpha is nothing but your effect. and this obviously depends on the moment of inertia. So that's our important relationship. Very, very important. Don't worry, Prasad. Watch my classes, watch how I solve, and then after that, solve the homework and watch the lecture in case you need it again, you need help, and then start solving basic, then medium, then mains level, then advanced level questions. You will get it. Alright. And remember one more thing. Some people also put this bar, which is also correct because it's a vector quantity. Alpha is also a vector quantity. So this just says that in whatever direction you apply the torque, in that direction it will have angular acceleration. So you apply the torque this way, it will accelerate like this. You apply the torque like this, it will angularly accelerate this way. That's all it says. Okay. So that's what you should know. The net torque is I into alpha. We're going to solve questions on this, and if you wanted the proof, don't worry, I have put it down here. You can download the PDF after the session is over from our Telegram channel. There is a link in the description box. Go find that Telegram channel link, join it. Every day we update it, we keep you posted with new notifications, updates, offers, etc. along with the PDFs, homework solutions, everything. So go ahead, join it. Chitra, I know usually my class is at 7:30, but today it's at 5:30 because of some other work. Okay. So let's get going. Here's the first question on your screen. Same torque is applied on a solid sphere with same mass and radius as that of a cylinder. The cylinder rotates about its axis, the central axis, and the sphere about its diameter. Then in the given time, whose angular speed will be more? Let's see how many of you can get this, my warriors. Come on, try this out. I'll make you visualize both these things. So what do we have? We have a sphere and a solid cylinder, both of same mass and same radius. So the cylinder rotates about its axis and the solid sphere rotates about its diameter. So what is the moment of inertia of a cylinder? Think it is mr square into 1 by 2. Yes, it is mr square by 2. It's same like a disk, and the moment of inertia of a solid sphere is nothing but 2 by 5 mr square. Now the equation that I just gave you was the torque is moment of inertia into alpha. It's clearly mentioned same torque. So this is basically same. But I is not same. Compare both of them. You will immediately understand this is half mr square, that is 2 by 5 mr square. Obviously 2/5 is lesser than 1/2, right? So half is obviously more, 2/5 is less. So hence the moment of inertia of the cylinder is more than the moment of inertia of the solid sphere. That means if this is more, alpha will be less to keep this torque constant. So alpha of the cylinder is less than alpha of the solid sphere. Is that making sense? If angular acceleration is more, think what will happen? Use this formula. Final angular velocity is nothing but initial angular velocity plus alpha into time. So in a given time, that means after some time, what will happen? The one which has more alpha will also have more omega. Hence, the answer will be the omega of the cylinder will be less than omega of the sphere. Hence, the correct answer will be option A, and I can see many of you answering option A. Yes, Chandrasekharan, my micro courses which I have conducted are still available, and trust me, it doesn't matter whether they are live or recorded, because the concepts which are cleared through these micro courses are very important, because I cannot keep conducting the micro course throughout the year. So I have made these micro courses because this is like a knowledge hub. You will enjoy it if you see it properly. Trust me, you will have a different perspective after the micro course. So I would suggest you to check even the recordings of my micro courses. Yep. Yes, Chitra, you should, I would say, set an alarm by hitting that bell icon and notify me for all updates, and also be active on Telegram channel group. Yep. So A is the answer. Moving on to the next question. Yep. So let's see what it says. So we have a wheel of 10 centimeters which can rotate freely as shown. There is a string which is wrapped over it, rim. Okay, and it is pulled by a force of 5 Newton. And it is found that the torque produces angular acceleration of 6 radian per second in 3 seconds. how much is the moment of inertia? How much is the moment of inertia of this wheel? So let's try to think what and all information is given and what do we need to find. Okay, I know the radius, I know the force, I know the angular speed, I know the time, I need to find out the torque. So I think to find out torque, if I go by this equation, torque is equal to moment of inertia into alpha. Okay, I do not know the moment of inertia. Oh, sorry, my bad guys. I don't have to find out the torque, I have to find out the moment of inertia. So I want to find the moment of inertia, so I need to find out alpha as well, I need to find out the torque as well. Acha, I think I know how to find out torque. Torque is R into F and into sine theta. Now if you look at the diagram, it is very obvious that this is nothing but R, this is nothing but F, and the angle between them is 90 degree. So I think I can find out the torque. R is nothing but 0.1 meter, force is nothing but 5 Newton, and it will be sine of 90, which is 1. So this will be nothing but 0.5 Newton meter. So that is the torque. Great. I think I need one more thing, which is alpha. I think I can find out alpha from this piece of information, because final angular velocity is 6, time is 3 seconds, and this starts to rotate, that means initial angular velocity is 0. I think I can use the equation omega final is omega initial plus alpha into t. So 6 is equal to 0 plus alpha into 3. So alpha will be equal to 2 radians per second square. Great. I found out torque, I found out alpha. The only thing left is moment of inertia. So torque, which is 0.5, is moment of inertia multiplied by alpha, which is nothing but 2. So moment of inertia is 0.5 divided by 2, which is 0.25. Units are kg meter square. That's it. Okay, Bhimashri, I think your net connection has gone bad. In YouTube, what happens is it automatically, according to the speed, adjusts the video resolution. So go to advanced settings or click the settings icon and select advanced settings and choose higher picture quality and or choose your resolution at least to 480p. Great. Zayed, I know many of you might be late from school, but it's okay, join in, and you can even go back a little bit behind in case you missed something and come back to the point where we are at 2x speed. Okay, so just do that. So that's how you solve questions, my warriors. 0.25 is the correct answer. Can we say acceleration is omega by t, which is equal to 2? Abhinav, we can say that only if, you know, initial velocity is 0. If it is not 0, then you cannot use a as omega by t. Okay, cool. Great. Let's move on to the next one. A wheel of certain mass, certain radius is rotating at an angular speed of 100 rpm. When the motion is turned off, neglecting the friction of the axis, find the force which must be applied tangential to the wheel to bring the wheel to a rest in 10 revolutions. So what's happening? There is a wheel. This is at t is equal to 0. It's revolving at 100 rpm. 100 rpm. I think I need to first convert it into radians per second, because you know all our equations go on with radians per second. 100 rounds per minute. So per second it is 100 by 60. One round is 2 pi radians. So these many rounds will be this much into 2 pi radians per second. This is very important. That's how you convert RPM into radians per second. First you convert it into per second, and you know one round is 2 pi radians. So just multiply it by 2 pi. So you will see few things get cancelled, and this 2 and this 6 will cancel to 3. So this will become 10 pi by 3 radian per second. Okay. Now what happens is you apply a force on it. Okay, you apply a force on it, which is obviously going to oppose it at certain distance. Again, this is R. This force will obviously create angular retardation. So that velocity which is like this will slowly go away and it will come to a halt. So there is retardation anti-clockwise. You can see that velocity is clockwise. So that velocity will die out after some time. I hope that makes sense. Now, after some time what happens? So that is after t is equal to t. This entire thing comes to a rest. Okay, so the question is, how much is that force which needs to be applied to bring it to a rest? Don't you see, it's got to do with torque is equal to I alpha, and it's very much similar to the previous question. Let's see how. Torque is equal to I into alpha. I think the wheel is like a disc, so I can find out I. Torque is R cross F, so from there I can find out force. Alpha, I think I can find out from this piece of information, because it is given that it should come to rest in 10 revolutions. So let's do this first. So I think I will use, let's see, which equation? Initial angular velocity is nothing but 10 pi by 3. Final angular velocity 0. Angular displacement is 10 revolutions. Each revolution is 2 pi radians. So 10 into 2 pi, which is 20 pi radians. And we need to find out basically the alpha. Which equation do you use? Remember the third kinematic equation? V square is u square plus 2as. Same way you have the third equation in rotation. Omega final square is omega initial square plus 2 alpha into angular displacement. Final angular velocity. What is final angular velocity? That is 0. Initial angular velocity. Well, that is 10 pi by 3, and that is square, plus 2 into angular acceleration. No, it's deceleration, so I'll just replace that alpha with minus alpha because I know it is retarding. So 2 into alpha into displacement, which is 20 pi. So bring these people over here. 2 into 20 is 40. So 40 pi will be 100 pi square by 9. Okay, one of the zeros went. This 10 and this 4 went. This will become 5. This will become 2. So I think I had alpha also over here. So yep. So alpha will become, oh, one of the pi also went. So alpha will become 5 pi by 18 radians per second square. So I found out alpha as well. Interesting. And only thing left now is moment of inertia. So the moment of inertia of a disk, how much it is? mr square by 2. So what is the mass? 10. So 10. What is the radius? Where is the radius? Radius is 0.2. So 0.2 square by 2. Great. So this will become 5 into 0.2 square. So 5 into 0.2 square. I'll just keep it like that. Maybe it might get cancelled somewhere else. Okay. Now let's use this equation. What is torque? Like I said, torque is R into F. So what is R? Okay, because torque is R into F. What is that R value? Just check this out. Radius is 0.2. So 0.2 into the force will be, what is moment of inertia? 5 into 0.2 square. Interesting. Into alpha. Alpha is nothing but 5 pi by 18. I hope you all can see that. Now let's see what and all will get cancelled, my warriors. 0.2 and this 0.2 got cancelled. 0.2 into 5, that's 1. Okay, that's it. I think next time only I have got the answer. The force is 5 pi by 18 newtons. That's it. That's the final answer. Interesting. How do you got change in theta? Oh, Bhimashri, delta theta gives you displacement, angular displacement. So this quantity over here, this is nothing but angular displacement. It is mentioned right over here, 10 revolutions. From the start, it takes 10 revolutions for it to stop. So the displacement angle wise is 10 revolutions into 2 pi radians, because each revolution is basically 2 pi radians. So Chimama, it depends whether the final answer is expected in decimal or whether it is given in the option form. You can use pi as 3.14 or 22 by 7 to get the answer in decimal values. But that's not so important right now. We are interested more in the concept. Yes, like I said, Abhinav, it depends on what the final answer is. Is it an integer type of question? Is it a options, whether all the options are given in pi or all the options are given in decimal. So that is just a detail. Okay, so that is not so important. All right, great. So that's a beautiful question. I think you are now getting a hang of how torque works with angular acceleration. Now let's slowly move ahead to pulley problems, because that's the main aim of today's class. See, we just now got torque is equal to I alpha, and till now in Newton's laws we used to solve problems like this, and our pulleys used to be ideal, and an ideal pulley, okay, an ideal pulley, the mass was 0. But we know in reality the masses are not 0, and because of which you might get an error in the answer. So what if the pulleys had mass? Well, let's see what difference will it make. First of all, you only think and tell me, imagine a system where the mass of the pulley is 0, and then this goes down, this goes up, this has some acceleration. Let's say in that case the acceleration is a1. Just imagine. This goes up, this goes down, the accelerations are a1. Second scenario, the mass of the pulley is not 0. Let's say the acceleration is a2. Which one do you think is more out of them? Is a1 more than a2? Is a2 more than a1? What do you suggest? If the mass of the pulley was there, what do you think will happen if you compare it with the situation when the mass of the pulley was not there? Think about it. Hi sir, long time. Okay, Dakshin saying A2 is more. Okay, Bhimashi has got it. Suchi also got it. Abhina also got it. Come on, my warriors. Think carefully. If the pulley had mass, what difference will it make to the acceleration? Will it be more? Will it be less? What will happen if the pulley itself had some mass? What will happen? Think about it. Abhinav saying A1 is more. A1 is more than A2. Yes, Roshni. Yes, Sairam, you are very early to the next class. Very true. A1 is more. Perfecto. A1 will be more because when the pulley has mass, then you have to rotate the pulley as well. So some energy will be spent in rotating the pulley. So hence, because of that, you will see the system will have lesser acceleration. So the forces will now not only have to accelerate themselves, but also will have to rotate the pulley, because of which zyada kharcha, too much spending. So that's why you will see the effect will be less, and you will see the acceleration with the pulley, okay, having some mass will be less. So A1 will be more, A2 will be less. Now, fair enough. Now, my question is, when the pulleys have mass, remember we used to draw these free body diagrams, something like this. There were tensions over here. You used to show tension here, etc. T, 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 T. There is a catch right now. You cannot do this. There is a small reason for that. I'll tell you why you cannot do this. See, just take the free body diagram of the pulley. What are the forces acting on the pulley? One is the force from the roof. The roof will be supporting that pulley. It's pulling it up. There is a hook. It's supporting that pulley. So there is a force from the roof. Obviously, there is a tension here and there is a tension here. And if one mass is going down, one mass is going up, the pulley is rotating. And if the pulley is rotating, it obviously has some angular acceleration alpha. Everybody fine? It has some angular acceleration alpha. Now if there has to be some angular acceleration, obviously there must be some net torque which is causing this angular acceleration. Who will create a torque? Let's see how we can do this. Let's see how we can do this. Okay, think about it carefully. If this alpha is there, this net torque must be there. Will this roof create a torque about the center? Obviously not. This roof is passing through the axis. So any force passing through the axis can never create any torque. Remember, I have told you. This force will create torque. This force will also create torque, but both are in the opposite direction. Yes, only tension can create a torque. Now think, if this tension and this tension both are at the same distance, both their torques will cancel. If this torque and this torque both cancel, then torque will be 0, alpha will be 0. But we know alpha is not 0. Hence, we should conclude that the tensions are not equal In fact, this will be T1, this will be T2, and T1 will be more than T2 for creating that alpha. So that's very important that the tensions on both sides of the pulley are completely different. Are you guys clear about this? Very, very important concept. So whenever you show the FBD, make sure you show T1, T1, T2, T2, something like that. So the tensions on both sides should be different. Okay, Himaya, Varshini, don't worry, I'll do that. Maybe sometime later, definitely. So the exact reason, Suchi, you will see it right now when I write the equations. Look at this. If I write the equation for the pulley, what will I write? Okay, what's the torque which is rotating, helping the alpha? Who is helping alpha? Is it T1 or is it T2? T1 is helping alpha, so positive torque. So R into F is T1. Which force is opposing the alpha? This T2 torque is opposite alpha, so negative torque. So R into T2 will be I of the pulley into alpha. You can clearly see that's the reason why T1 should be more than T2. I hope that makes sense. Because if T1 is less than T2, then this will be negative. And if T1 is equal to T2, this term will be 0. That's the reason why T1 is more than T2, because it is trying to rotate that way. If by chance alpha was like this, then your equations will change. Then you will write R into T2, because T2 torque will be positive, minus R into T1 will be I into this alpha. So that's how your equations will change. I hope that makes sense. Harita, you have missed a lot, but you can go behind because otherwise you might find it a little bit difficult. So all those students joining in a little bit late, please go a little bit behind and you can even catch up during a live session. All right. So that's what it is. Let's solve some questions based on this. So whenever the pulley is massive, the tension on both sides of the string will be different and the angular acceleration of the pulley will not be 0. Be careful about that. Yes, Suchi, on the second case, T2 will be more than T1. Correcto. Let's solve this question. It's a beautiful question which has come up on your screen. So read the question carefully. In this arrangement, the masses are uniform. The pulley is of some radius and has some mass m. The masses of the two bodies are m1, m2. The thread does not slip, and that's why the pulley rotates with it. Find the ratio of T1 by T2 in the threads because of these scenarios out there. So what is happening is, let's say M1 is massive, example. So it goes down, it pulls the thread, this pulley starts rotating, M2 goes up, and because of this there is some tension T1 and T2, and we need to find out what is the ratio of T1 and T2. Okay, so what should we start with? Everything obviously starts with free body diagrams. So let's start with free body diagrams. So first, for M1 mass, there will be M1G. Remember, I told you the tensions on both sides will be different. So if here I show T1, here I should obviously show T2. This string has a tension T1, so I'll show T1 upwards on the block. Remember, tension always pulls the ends. So this string will pull the block. Okay, tension will always try to pull the block like this. Remember that. Okay, great. Next, on M2 there will be tension T2 like this, and obviously there will be M2G. Interesting. If M1 is massive, then it will accelerate downwards and this will accelerate upwards, and if this goes up, this goes down, obviously it will cause a rotation, angular acceleration alpha. You will notice every time I draw FBD, I always show the effects in the FBD. I never skip accelerations or angular acceleration because it gives you a sense of which one is positive, which one is negative. Now, let's try to write the equations and see what do we get. For M1 first. So for M1, what will my equation look like? T1 is positive or M1G is positive? See which force is supporting the acceleration. Obviously M1G is supporting. So M1G minus T1, that will be the total force. Larger force minus smaller force is mass into acceleration. So that's why I will say M1G minus T1 is equal to M1A. Interesting. Similarly, for M2, what will you say? Look at it. Larger force minus smaller force is mass into acceleration. So you will obviously say T2 minus M2G is equal to M2A. Similarly, for that pulley of mass M, you will not write F is Ma. See, these two masses were moving up and down. So that's why you'll use linear equations, F is Ma. That pulley is not moving up and down, it is rotating. Hence, you will use torque is I alpha. So now think, there is a torque which is causing that acceleration. T1 is causing positive torque, T2 is causing negative torque. So the total torque will be for the pulley R into T1 minus R into T2 will be equal to moment of inertia into alpha. Okay, is the moment of inertia given? I think, we have to assume it as uniform solid cylinder. That means mr square by 2. So mr square by 2 into alpha. Interesting thing, R and one of the R gets cancelled. But one more interesting thing is there here. Alpha and A are also related. What is the relationship between A and alpha? Think about it. If this is the pulley and this is the tangential acceleration, because that acceleration will be going to the thread. So what is the tangential acceleration relationship with alpha? A is alpha into R. Do you remember this? A is alpha into R. So basically, what is alpha? This alpha is basically A divided by radius. A divided by radius, correct. So hence one of the R which is left here and this R will also get cancelled, and I'm just left with T1 minus T2 is equal to M into A divided by 2. Very interesting. Okay, now see, there are equations which are formed, and remember our final goal is to somehow find T1 by T2. Let's figure that out, that's not a problem. But to find that out, I think I need to eliminate A somehow. Now in order to eliminate A, what do I need to do? Interesting. So how about adding all the three equations? Maybe just let's add all the three equations and let's see what happens. So if we add these equations, okay, adding the three equations, okay, let's see what do we get. T1 and this T1 gets cancelled, T2 and this T2 gets cancelled. I hope you can see that. So M1G minus M2G, T1, T2, T1, T2 have got cancelled. Okay, so it's all gone, and is equal to M1, M2 and M. Okay, so M1A plus M2A plus M by 2 into A. Very cool. So just the next step will be basically take G common, take A common. So M1 minus M2 into G is equal to M1 plus M2 plus M by 2 into A. So therefore A will be equal to, just bring this down, M1 minus M2 divided by M1 plus M2 plus M by 2, the whole thing into G. So this will give me the acceleration. I think now I can figure out the tension 1 and tension 2 ka ratio. I'll tell you how. From this equation, T1, okay, T1 will be M1, think about it, take T1 there, take M1A over here, M1G minus M1A, and from here T2 will be, just bring this over there, M2G plus M2A. Now I'll just get rid of this equation, I don't need this anymore. So just divide both of them. So what is T1 by T2? So if we divide T1 by T2, from here M1 is common. So M1 into G minus A upon M2 into G plus A. I think now you know what to do. It's just matter of substitution. I think that is a detail which you can easily solve. Just put A over here and you will get the answer. Yes, it is definitely related to circular motion, Suchi, definitely. But I think after this you can solve. But you get the gist of it? Did you get the idea of it? Okay. Now, how about me teaching you guys a trick which will avoid you many equations? Are you ready to listen into a trick? Are you ready to listen into a trick? So Abhinav, right now we are in the third class. By next week, I think we should be done with the rotational motion. Okay. Now I'll tell you what, this trick helps you a lot in figuring out the acceleration and avoids all the unnecessary trouble out here. So I'll tell you what it is. So let's just ignore this, all these things. Okay, it's not needed anymore. It's basically opening up method, or basically bigger force, pulling force minus opposing force upon total mass. I'll tell you what this formula is. Acceleration's direct formula will be the pulling, or basically the greater force, the one which is greater, minus the opposing force divided by the masses, the sum of the masses, the total mass ka sum. That's it. And the masses which are translating will be just added, but this rotational mass, or rather the pulley, is not actually it's not actually translating. Only M1 and M2 are moving. This pulley is rotating. So whichever masses are just rotating, those masses you have to consider the equivalent rotational mass. You have to consider the equivalent rotational mass. Look, sir, what is this equivalent rotational mass? It's very easy. See, for example, if it's a solid sphere, what's the moment of inertia formula? 2 by 5 mr square, correct? So the equivalent rotational mass will be 2 by 5m. That's it. If it is a ring, what is the moment of inertia? mr square. So the equivalent rotational mass will be just m. That's it. If it's a disk, it is mr square by 2. So m by 2 is the equivalent mass. As simple as that. So let's just try to use this and see what do we get. Okay. So pulling, the greater force minus the smaller force. So m1g is the bigger force for that entire system. So m1g minus opposing, this is opposing the motion, so minus m2g upon the translating masses m1 and m2. So m1 plus m2, these are the translating masses, plus rotational mass. This is the rotational mass. Remember, this is the solid cylinder. So actually the moment of inertia formula will be mr square by 2. So the equivalent rotational mass will be just m by 2. So don't you see, I can directly write down the acceleration without having to solve those equations. Isn't it easy, simple? Isn't it easy and simple? Yes, I think the next class will happen day after tomorrow, okay? So stay tuned. But tomorrow there will be a class for 12th standard. Amazing, right? So this will help you a lot. Now let's solve another question based on this simple trick, and you will see how much time you will save. Okay, by the way, this was the answer when you substitute acceleration value and try to find out T1 and T2 ratio. Let's try to solve this question by my trick. How can we say MOI without mentioning axis of rotation? Bhimasri, it was given that it is hinged over here, so we know this is the axis of rotation. So that's it. That's the equivalent rotational mass. That's how you can get it. Okay, so it's very easy. So in this case, there are two pulleys, two masses. Just imagine if you had to draw FBD and solve this question, what would happen? Just imagine this. So first of all, this weight, this tension, so 3 mg, T1, this is T1, this is T2, okay, this is T2, this is T3, this is T3, this is mg. Okay, this will accelerate here, this will have angular acceleration here, this will also have angular acceleration here, and this will accelerate upwards. My God, look at this. 1, 2, 3, 4, 4 bodies, 4 FBDs, 4 equations, A is equal to alpha. Solving it will take you a lot of time. Let's solve this. Let's solve this using my trick. Aishwarya, you're a little bit late. It's okay. I know today's class was a little bit early, but definitely you should catch up, Aishwarya, because today's class is very important. Okay? Chalo. Let's do this using my trick. The bigger force, the pulling force. What is the pulling force? Come on, my warriors. It is 3 mg. Let's see how many of you can use my trick and post the answers before I finish it. Opposing force. What is the opposing force, my warriors? It is mg. Okay. Upon the masses which are translating. 3m and m are just translating. So 3m plus m. These are the translating masses. Plus rotational equivalent of the masses. The pulleys have a mass of 2m. Now what will be the moment of inertia? The moment of inertia will be mass into r square by 2. Okay, so what is the equivalent mass? It is just m. So m is the equivalent mass. So hence I should put, for this pulley it is m, for that pulley also, because each of them are the same thing. So m plus m, that's the answer. And let's see, 3m minus m, it's 2m. So 2mg divided by 3 plus 1, 4, 4 plus 1, 5, 5 plus 1, 6. So 6m, mm gone, 2 and 6 gone. So 3, so it is g divided by 3. Wow, very good Pranesh, excellente. Suchi, I think you missed one of the m's. One of the m's you missed. Okay, great, great Roshni. Oh, Roshni also got it. Perfecto, perfecto. Excelente, excelente. Okay, glad Aishwarya. I mean, I'm so happy that students take a break in my class. I mean, how relaxed are these classes? I want to know. I mean, or rather it is very obvious and it's very evidently seen. I'm so happy that you guys take break over here. Very good. Keep it up. Usually I've seen people go out of a class because they want break, but here they are taking break. I'm so happy. Great, great. Oh yeah, you are in Vipro. I know. Yes. Next class will happen on 7:30. Next. I mean, the day after tomorrow. Okay, moving on to the next question. Beautiful questions coming up on your screen. There are amazing questions which will blow your mind, and here it is. There is a cylinder of certain mass. It's suspended through 2 strings. You would have definitely done this, especially when you take a reel of a thread or something which is wound, and suddenly it slips out of your hand and it just falls down. Have you experienced that? You have wound something and you, by mistake, you forget to hold that object or that roll, and you just hold the thread and that entire thing starts falling down. So here there are 2 threads and the entire thing starts falling down, and the question is, what is the tension in the threads? What is the tension in the threads? Let's see how to do this question. So first of all, obviously, what do? Start with free body diagram. But this diagram this view is a little bit difficult to visualize. So I will look at the side view. So if I see from here, what exactly will I see? I will see both the threads over here, and I will see this reel or this particular cylindrical object like this, and the center over here. And what I will also see is both the tensions are upwards. So I should put over here 2T, because these threads are one after the other. You cannot see it. They are one behind the other. Okay, so I'll just put 2T over here. This center will experience mg force down, and this center will also have your acceleration towards the ground. Okay, this entire thing will start rolling down. Just visualize this. Right now it is here. Okay, after some time, this thing will be here. After some more time, this thing will be here. So I hope you can see the center is definitely accelerating downwards. Not just that, it is also rotating. So hence it also has rotational acceleration or angular acceleration. That's it. These are the only things which are there on it. Now try to think about it. If I write the Newton's law equation, what is the Newton's law equation? Net force is mass into acceleration. The only forces are tension and weight, nothing else. So bigger force minus smaller force is mass into acceleration. So hence I will say mg minus 2t is mass into acceleration. Great. Next, take the torque about the center. Sit on the center and take the torque about it. The moment you sit on the center and find out the torque, there is one catch. Remember, this center is actually accelerating. So the moment you sit on the center and then try to solve the problem, it's a non-inertial frame of reference, because you're trying to measure the torque about this. The moment you are in a non-inertial frame, what should you do? Apply pseudo force. So where are you accelerating? Down. Where will the pseudo force be? Up. So there must be a pseudo force upwards. Man, this is crazy. This is crazy, isn't it? Now, here is the next part. If I use net torque is I into alpha, the torque will be there because of pseudo, tension and mg, three forces, so three torques. But guess what? Mg and pseudo both are passing through this axis. So what will be their torques? Come on, my warriors, think about it. What will be the torque due to pseudo force or mg? Because both of them are passing through the axis. Will it be positive? Will it be negative? Will it be zero? Come on, put it up in the chat box. Come on, my warriors. This is straightforward. Yep, come on, think. Excellent, Chandan. It will be 0. R is 0. So R cross F is 0. So both pseudo and gravity will not give torque. The only force which will give torque is this 2T force. So look at this. This 2T force is at this distance R. So R cross F, that torque will give this alpha. You can see that this 2T is giving that alpha over there. So I'll just put over here R into 2T, okay, plus 0 plus 0. Why is this 0 plus 0? I'll mention it over here. Mg and Fp give no torque. That's the reason for that. Is equal to moment of inertia. It's a cylinder. So moment of inertia of a cylinder is mr square by 2 into alpha. Very good. The moment you get this, let's cancel out few more things. R gone. So I'm left with 2T is equal to m by 2 R alpha. Wait a minute. I think I know what is the relationship between A, alpha and R. I think I know what it is. So what is this? R into alpha. That is nothing but A, right? So next step, I'll just take this 2 over here. So 4T will be m into A. I think I have solved most of the question now. Just take this MA and put it over here and see what do we get. Okay, so let's see what do we get. So we will get mg minus 2t, okay, is equal to ma, but ma is equal to 4t. So mg is equal to 6t. Okay, I think I'm lacking space, but tension will be nothing but mg by 6. That's the final answer. Done. Isn't it amazing? This thread which was being held and suddenly that spool or that reel started slipping, it slipped out of your hand, it starts falling down. You have just figured out how much tension is there in those threads. It's amazing. It's mg by 6. What a brilliant question. If there was one thread, then it will be 2 mg by 6 or rather mg by 3. Beautiful question. So that's the answer, mg by 6. Clear, all right? Hi Jacob, you're little bit early for the next class. Okay, today's class started at 5:30, but you can definitely start watching the replay or go back, slide the slider, start from the beginning because today's topic is very important. And if you're loving these questions, do not forget to smash the like button and hit the subscribe button if you're new to this channel so that you do not miss my classes. Get ready for the next amazing question on your screen. Hi Panavalayam Suluvai, welcome aboard. Good evening, bacha log. This question, okay, in the figure given in the text, okay, I think there is some misprint. Okay, just ignore that. There is a rod, just forget that. There is a rod, okay, there is a rod, and what happens is it is being held by both the strings. Okay, it is being held by both the strings. So there is tension and tension over here. Now, the question is, find the tension in the other string when one of the string is cut. Let's say you bring a scissor. Okay, you bring a scissor, okay, and you cut this string. The moment you cut this string, obviously this rod will start tilting and start going down. So the diagram will now change to something like this. You'll have just this string over here, and this rod will just start to, you know, bend and it will start to come down, something like this. Okay, so it will definitely have some angular acceleration like this. So the question is, what is the tension in this particular string? That's the question. Beautiful question. Let's try to solve this. Okay, let's start obviously with the free body diagram. Without that we cannot go ahead. So we have to find out this tension. think what are the other forces acting on it. I'll remember you very properly if you attend my classes every day and you post the answers in the comment section after the video ends, trust me. Okay, so let's see what are the other forces. Obviously weight will be there. Okay, there is a weight acting downwards like this, mg. I think apart from this there is no other force. Well, tension is there, mg is there, and the center of mass, the entire rod center will have an acceleration. So it will have acceleration downwards like this. What do you think is the relationship between A and alpha? Because I think I will need it. Oh yes, Remo. Please change your name, Remo. Why everybody keeps different names? It becomes so difficult. I remember last time also I said the same thing. Anyways, so what is the relationship between A and alpha? I'll just give a hint. The total length of the rod is L. Okay, just think. So what is this much length? This much length is L by 2. And what is A? A is alpha into R. Just think about it. This center is going in a circular path like this. This is the circular path. If this is the circular path, this A will become the tangential acceleration. Yes, it is alpha L by 2. Correct. A is nothing but alpha into length divided by 2, because this is the radius, not this. This is the radius. So this is the axis about which it is rotating. Perfecto. Great. Now let's write down our equations and see what do we get. Net force is mass into acceleration. If I use Newton's laws, the only two forces are mg and tension. Okay, so the only two forces are mg and tension. So let's see what do we really get. Bigger force minus smaller force is mass into acceleration. So bigger force minus smaller force is mass into acceleration. Fair enough. Let's keep it like that. Net torque is I alpha. So rotational equation, if I use it. If I use it about this point, think that will be better, because then the torque of the tension will just vanish off. So there is no torque of the tension. So I will just put 0 over here. But mg is creating a torque of L by 2 into mg. Can you see that? R into F. R is L by 2. So it is nothing but L by 2 into mg is moment of inertia of the rod about the end. So moment of inertia of the rod about the end, be careful. It is not ml square by 12. Be careful about it. You have to shift the axis from the center to here. This is the axis. So ICM plus M into shift square. That's the parallel axis theorem you need to use, into alpha. Okay, but alpha is nothing but 2A by L, I guess. Okay, I'll just see what we can do about it. Okay, just alpha is nothing but 2A by L. So I'll just put it over here. You can see that from here. Alpha is 2 into A divided by L. Okay, interesting. Let's try to solve this and see what do we get. L mg by 2 is equal to center of mass के about the moment of inertia is ml square by 12. Shift is nothing but L by 2. When you solve this, how much answer will you get? What will you get? What is the moment of inertia of the rod about the end? Come on, quickly calculate in your rough books and figure it out. Come on, quickly figure it out. What happens? Ml square by 12 plus m into L by 2 whole square. Because this will be L by 2 into whole square. This is shift square. What will be the answer that you will get? I think you should get it as ml square by 3. Just check this out. Are you getting ml square by 3, my warriors? Just see if you are getting ml square by 3. So this should come out to be ml square by 3 into 2a by L. Now what and all will get cancelled? L, L, this L also, and this M also got cancelled. And from this I got A is equal to 3 goes up, 2 comes down, 2 2s are 4, 3g by 4. So acceleration came out to be 3g by 4. What do you do next? Yep, just put this over here. Just use this acceleration over here and see what do you get. So just use this equation and see what do you get. Okay, let me just solve it over here for you. 1 second. Yep. So mg minus t is equal to m into a. A is nothing but 3g by 4. Bring the tension here, bring this term over here. So mg minus 3 mg by 4 is equal to tension. So tension will be 1 minus 3 by 4 is 1/4. So it will be nothing but mg by 4. So that's our final answer. See this. So that's how you solve the question. So every time, what are we doing? Starting with free body diagram, finding out the relationship between alpha and A, then marking the tensions properly, making sure the directions are as accurate as possible, making sure the sign convention is correct, and lastly we are writing down F is equal to ma and torque is equal to I alpha, and just it's a matter of maths after that. That's it, isn't it? So I'm pretty sure after this you are going to get some confidence and you are able to understand how the problems are solved in rotation. The last part of today's class is rotational kinetic energy. Are you guys ready for it? Rotational kinetic energy. Okay, cool. So let's see what is rotational kinetic energy. All right. Now, imagine a fan. Okay, it's rotating. It has kinetic energy. If I want to find the kinetic energy of the fan, very easy way of doing it. Here it is. So kinetic energy of rotation is, think this way. Imagine the fan or any rotating object is made of multiple particles. Let's say this is mass m1, okay, and it is moving with some speed v1 and it is at a distance of, let's say r1. Some other particle, let's say m2, will be at some other distance r2, and it might, okay, if it is rotating, I don't know, like this, it has some velocity v2. So each particle of different mass will have different distance, different speeds, and each of these speed like v1, v2, etc. will be omega into r1. This will be omega into r2. Agreed? So the total kinetic energy of a rotating body is nothing but kinetic energy of this particle, kinetic energy of this particle, this particle, that particle, this particle. Add all their kinetic energies, the total kinetic energy will give you the rotational kinetic energy. That's all. So it's nothing but K1 plus K2 plus Kn. What is K1? Half m1 v1 square. Similarly, you will have many terms because there are many particles in it. Last term will be mn vn square. Make sense? Okay. Now see what is v1, v2, v3. v1 is omega r, v2 is omega r2, and so on and so forth. So this will be half m1 omega square r1 square till the last term half mn omega square rn square. Notice a few things like omega is same everywhere and half is also same everywhere. So I think I can take out as common. So half omega square, what is the first term? m1 r1 square, and like that, what is the last term? mn rn square. Is the term inside the brackets very familiar to you? Is the term inside the brackets very familiar to you? I think it is. You know that from the last lecture that it is nothing but the moment of inertia. So that's it. I'll get it as half omega square into moment of inertia. So that's your rotational kinetic energy. Now if you are wondering, how do I remember this formula? Well, this derivation is obviously important, but this formula of rotational energy, which is half I omega square, is very easy to remember because kinetic energy of translation is half mv square. And notice the resemblance. Mass is similar to moment of inertia, velocity is similar to angular velocity. So instead of half into mass into velocity square, here it is half into moment of inertia into angular velocity square. That's the only difference. So that's very easy to remember. Yes, they are all rotational equivalents. Correct, Roshni? That's all. Exactly. So let's start solving some questions so that you know how this formula can be used for solving some questions. All right. So let's do the first important question. By the way, the derivation again I have put it up, and if you are interested in downloading all of this, then definitely you should join the Telegram channel of Enthuse, and the link for joining the channel is there in the description box below. So let's look at the first question, and here it is. Estimate estimate the total rotational kinetic energy of the earth? Amazing question. Total rotational kinetic energy, just imagine. Make suitable assumptions and let's just see how much does it come out to be approximately. Can I take the earth as a rod, ring, disc? What should I take it as? Come on, my warriors, what should I take the earth as? Yeah, think about it. I think Remo, somebody just mentioned how to change the YouTube channel name. You just have to go to account settings and just change the name somewhere over there. Yeah, it's a solid sphere. Very good. So the rotational kinetic energy of the spin will be half moment of inertia of the solid sphere into omega square. Okay. What is the moment of inertia of a solid sphere? It is 2 by 5 mass of the earth into radius of the earth square into omega. Now I do not know omega, but I can find it out by this formula, which is 2 pi by time period of rotation. So it is 2 pi by t, and that is obviously whole square. That's from circular motion. 2 goes off, so I'm just left with m r square by 5 into 4 pi square by t square. Great. Now it's just a matter of substitution. So what are the masses, radius, etc. that you will substitute? I'll just tell it to you. This mass of the earth is roughly 6 into 10 to the power 24 kg. Okay, so the mass is 6 into 10 to the power 24 kg. Radius of the earth is 6.4 into 10 to the power 6 meters. Okay, so that's squared into 4 into pi square is roughly 10. Okay, if you do 3.14 square, because 3 square is 9, 3.14 square roughly comes out to be 10. So we can make suitable assumptions. Divided by 5 into time of rotation. Remember, the earth takes 24 hours for one rotation, but don't leave it in hours, convert it into seconds. It comes out to be 86,400 seconds. So that's the time value. When you multiply, one rotation takes 24 hours, 1 hour is 60 minutes, 60 minutes is 60 seconds, 1 minute is 60 seconds, so 60 into 24 will give you 86400. So just put it over here, 86400, and then square it, and then check out what is the answer. Okay, so that's what you need to do. Yeah, so this answer comes out to be very, very huge. Okay, this answer comes out to be very, very huge. Okay, somewhere I think this is 32 if I'm not wrong. Okay, just I'll change it over here. This is I think around 32. So 2.3 into 10 to the power 32 joules. It's a big amount of energy. I mean, just to give a perspective, if you explode a nuclear bomb, roughly a small nuclear bomb, it creates energy in the range of 10 to the power 14 or 15 joules. Okay, one atomic bomb creates an energy in the order of 10 to the power 14 or 15 joules. This is 10 to the power 32. Like, sir, 10 to the power 14, 15 and 10 to the power 32, very close, sir. 14 and 32, very close. No, my warriors, it's huge. That's very big, yes. Think about it, the difference is almost like 10 to the power 18 or 10 to the power 17. So 10 to the power 18 or 17 means if you explode one nuclear bomb, that energy which is created, you multiply 10 to the power 17 times. Imagine the number of zeros that will come. That much energy is there just with Earth's rotation. Isn't it massive? Isn't it massive? It's huge. So that many trillion times is what the Earth has. So you cannot expect, I'm going to stop it, sir. I'm just going to rub it and I'm going to make the Earth stop. No, you cannot. You do not have that much energy. Okay, moving on to the next question. Yep. Let's powerful enough to blow a few planets as well, Roshni, I think. Yes, trillions of trillions, correct. Kinetic energy is equal to centripetal force. Wrong, Selva Kumar, that's not true. Okay. Koi nahi. Divya, I think you missed quite a lot, but it was fun session. But please watch the replay, Divya, because very important session, and I really don't want you to miss this, because else you will face difficulty in the next class. Okay, great. Yes, so let's move on. Oh, Jadhav, I think it is Srashti, if I'm not wrong. Yep, is it? Yeah, Srashti, who is there as Raji Pratap Jadhav. Okay, yeah. Welcome. Join in, bacha log. I think you guys are joining in now because your schools or colleges were over and you are used to my 7:30 time slot. Okay, chalo. Let's get going to the next question. A wheel rotating at angular speed of 20 radians per second is brought to rest in 4 seconds. If the moment of inertia is given, how much work is done by the torque in the first 2 seconds? Come on, let's see how to do this question. Okay, how much work is done in the first 2 seconds? So first of all, let me tell you, if you look at this wheel is rotating at 20 radians per second. So it is rotating at 20 radians per second and it is brought to rest, in 4 seconds. Now the question says work done by the torque in the first 2 seconds. After 2 seconds, can you guess what will be the angular speed? Think carefully. After 2 seconds, what will be the angular speed? Because in 4 seconds it stops. So after 2 seconds, what will be the angular speed? Because it is uniformly decelerated. Think about it. Why is this a straight line? Because it is uniform. We are assuming this uniform retardation. So what will be the speed? Come on, my warriors. Excellent. 10 radians per second. Perfect. Now, because the question says work done first 2 seconds, I somehow got a deja vu of last chapter, work, power, energy. So how about using the work done by the torque goes in changing the kinetic energy of the system. The work done has just gone in changing the kinetic energy of the system. So right now it has some speed, finally also it has some speed, so kinetic energy has changed because the speed has changed. So how about this? It is nothing but half I omega final square minus half I omega initial square. Moment of inertia is same, so I can take out common and it is clearly given to be 0.2. So half into 0.2 into final angular speed is 10, so 10 square minus initial angular speed is 20, so 20 square. So 0.2 divided by 2 is 0.1 into 10 square is 100, 20 square is 400, 100 minus 400 is minus 300, minus 300 into 0.1 is minus 30 joules. That's the answer. And why is the answer negative? Because it has retarded it, the kinetic energy has reduced, so hence the negative work. Okay, Ranveer, perfectly. I have discussed many rotational Erode problems, momentum problems, center of mass problems in my Erode micro course. So if you are a part of the pro subscription, you can just search for Shreyas Sir Erode course or Shreyas Sir Erode. You will get my Erode micro course. I have done detailed discussion of so many rotational motion problems. You definitely do not want to miss that Erode problem solving course. Okay, chalo. Abhirami, you are not able to see my batch. Okay, just do one thing, Abhirami. Just wait for some time. I'll show you how to join my batch. There is a video which you need to check, or just do one thing. Leave a comment after this video ends. Okay, I'll respond to that comment. Okay, or just wait for some time. I'll show you how to do that. Area under the curve will not give you. Remember, Selva, force versus displacement area gives you work, but this is neither force nor this is displacement, so this area will not give you work. Okay. Green Kerala, I would suggest please watch my Pathfinder series electrostatics classes, and then also check out my pro subscription related micro courses are there. But if you are not in vPro, then I would suggest please watch all the classes of electrostatics and Gauss's law. I have done everything in detail. Trust me, you will understand it. Okay, Green Kerala, you can find the playlist. It's there on this channel itself. Okay. Now, this answer should be minus. I'll just change it before you get the PDF. Okay, moving on to the next question. Let's see what it is. The There is a rod, it is held vertically on a rough floor. It is left, it falls without slip. Okay, so what happens? This rod, it falls down. Okay, my rod fell right over there, but just imagine it just falls like this. So when it falls like this, just when it is about to hit the ground, what is the angular speed? Beautiful question. Beautiful question. The answer is not 0. Okay, so the answer is not 0. Okay, I'll tell you. So the rod starts rotating, it falls. So the question is over here, what is this angular speed? Okay. Now, can you guess what is the axis of rotation? Come on, my warriors. Surinder, I have put in a lot of effort, bacha. So that's the reason why the course is there in the pro subscription, but it is free of cost for all the vPro members. Okay, so if you're a vPro member, you can try it out for even 15 days. Even for 15 days, you can buy the vPro. It's for 750 rupees. So understand, it takes a lot of effort to store that data, to have a lot of work going by the content side, going by my side. All right, so that's why some things are free, but some things are chargeable. We try to do as much as possible free of cost, but there are limitations to that. I hope you understand, because obviously there's a lot of hard work that goes in behind the scenes, which probably you'll understand when you grow up. Okay, so as far as possible, we have tried to keep the cost as minimal as possible. So even today, if you buy the pro course, it's for 750 rupees, and it's a deal which is only there till tomorrow. So try it out. The link is there in the description. Okay, come on. So, okay, come on, think. Surinder, this is advanced type of content, and I am not sure if you have checked our entire channel. You will see so many advanced classes, especially advanced classes, but otherwise most of our classes are mains plus advanced. So it's wrong to say that advanced classes are not there. In fact, you should definitely check out my playlist on YouTube. There are so many playlists, there are so many lectures which you will find dedicated for JEE Advanced. Okay. Now, moving on, what do you think is the axis of rotation? The axis of rotation is this bottom point. Great. So this has rotated and it falls down. So should I go by torque? I think no, because as it moves, mg force will keep moving and the torque will keep changing, alpha will keep changing. So it will become non-uniform motion. Instead, I will try to keep it simple and try to use work power energy principle. Basically, energy conservation. Think from this state to that state, some energy got converted into some form of energy. If you mentally try to visualize which energy got converted into which form of energy, that's really good. And if you have figured that out, type it up in the chat box. Which energy got converted into which form of energy from here to here? This is initial, this is final. What energy got converted into what form of energy? Put it up in the chat box. I would love to see it. Think about it carefully. What is that energy which got converted into which other form of energy? It's very simple. When it is here, it had some energy. Exactly, Chandan. Yes, potential to kinetic. And to be more specific, it's the gravitational potential energy which got converted into rotational kinetic energy. Why rotation? Because it is rotating about that axis. You can see that. And just before hitting, it is rotating about that axis. Okay, you can just visualize it. Now, how much is that gravitational potential energy that it had as compared to this reference? So if you assume this as 0 reference, always remember, whenever you have a big body, check where the center of mass is. Obviously, the center of mass is over here. Can you see that? The center of mass is here. And what is this distance? What is this distance? Obviously, it is L by 2. So, to find the potential energy of the rod, just find the potential energy of the center of mass. So, m, g, h. H will be L by 2. So, m, g into L by 2. That's the gravitational potential energy. Next, rotational kinetic energy will be nothing but half moment of inertia of the rod into omega square. 2 gets cancelled. So mgl is equal to I. What is moment of inertia of the rod? Be careful now. Okay, let me tell you that. Because this I is not about the center, it's about the end. So moment of inertia about the end has to be found by shifting the axis. Yes, shift the axis. Come on, my warriors, use parallel axis theorem. It's ICM plus M into the shift square. ICM is ML square by 12. Shift is nothing but L by 2. So when you do the math, just check it out. L by 2 square is L by 4. 1 by 4 plus 1 by 12. If you do the math, it will come out to be ML square by 3. Yep, the standard ML square by 3. That's what you need to remember. A lot of people write it as ML square by 12. That's a wrong answer. Okay, it is ML square by 3 because it's rotating about the end. So that I should be about that rotational axis. So hence it will become ML square by 3 into omega square. Now so many other things will get cancelled, like this M, this M, this L, this L, and I think I can take this 3 over here. So 3G, L will come down, is equal to omega square. So omega will be root of 3G by L. That's our final answer. What's the angular speed when it is just about to hit the ground? Okay. Abhirami, like I said, I'll just tell you about it. Okay. Okay, great. Pranesh, it's most likely going to be February end or March first week. What an amazing question, 3G by L. Now there are 3 homework questions. I want you to post the answers in the comment section. This is your first homework question. Try to solve it. The second homework question and the third homework question. This is the second homework question. This is the, oh sorry, my bad. Wait, I think there is a mistake or something. Okay, this is the first homework question. This is your second homework question. And this is your third homework question. Okay, and let me also show you the winners and all the lovely warriors who have posted the answers last time. Let's have a look at it. Where are we? Yes, yeah, I think this is the lecture. Yeah, oh yeah, it is. This is the one. Beautiful. Let's see. Oh no, this was the lecture. Yeah, this is lecture 2. Yep, yes, this is lecture 2, correct. So very good, Chandan, Ishpreet, XS Mars, very good, Harita, Yash, glad Vani ma'am student and my student too, very good, Chitra, very good, David. How many classes of physics will be there per week on this channel? Around 2 to 3, minimum 2, but most of the times you will see 3 classes. Okay, very good, Gokulnath, very good, Sairam. Will I respond if I'm free? Yes, I'll try to respond. And yes, good work. So please post the answers in the comment section like this. And now, those of you who are not able to find my courses, I'll tell you what you should do. See, it's very simple. Just do one thing. Watch this video, which I'll tell you. Okay. Just search for Shreyas Sir Pro. Okay. Just search for Shreyas Sir Pro. Just watch this video, Shreyas Sir Pro subscription. In this video, okay, let me just skip this, probably it takes some time. Okay, let me just try to skip it again. Okay, just 1 second guys. Yep. So over here I have detailed out how do you search for my classes. See, one is the Rodo course, and then you will see HC Verma course, derivation course, all these things. Okay, what do you exactly put in the search bar and how do you exactly search for it? It's mentioned over here. Just do that. It's very simple. You will definitely be able to get it. Is that okay, Abhirami and others who are not able to get it? Okay, I hope this is fine. Yep. Great. Cool. Excellent. Eppadi irukunga, says Chitra in Tamil. Eppadi irukunga means how are you, I guess. Eppadi irukunga. Oh my god, I was so different during that time. Okay, maybe I should color my hair. How to increase the speed of problem solving, Harita? By solving more and more problems, solving more variety of problems, by hearting and remembering tables, values, constants, and be fast at calculations. When you practice a lot, when you practice a lot of variety on your own, then it starts clicking how to solve it, then your speed automatically increases. Practice is the key, and try to avoid the mistakes which you do and not repeat them. That's all. Okay, cool. Okay, so Surinder, that Irodo course is already there. I will not do duplicate work over here. So just watch that because not many people are interested in Irodo course. because there is a specific kind of people only who are interested. So if you are that kind, I think you should definitely go ahead with it. Do not look for just YouTube classes on Aerodove, that will just probably waste your time. Instead, attend this course, plus there is my problem solving course which you will be benefited from. And let me tell you right now, the offer that is going on is basically, you can see it's 750 rupees. Yeah, 750 rupees means you will get everything. So why do you want to wait for some more time and lose out on this offer? So when you use the discount coupon code SHHPRO, you get the light version for 750 rupees. If you are interested in the classic version where you get the doubt solving on the mobile app, go ahead. It's 1000 rupees. It's not much. It's like your pocket money. 1500 you get personal mentor, personal guide. That's in the plus version. Yeah, just what you can do. Okay. So Surinder, yes, exactly. This is exactly for 15 days. You can download and you can use my Aerodove course even for 15 days. Just try it out. Trust me, you will love it. Okay. Cool. Thank you guys so much for being here, and I hope you have enjoyed this class. And if you enjoyed, do not forget to hit the subscribe and the like button, and do not forget to recommend this channel to your friends, because that's how we are going to make this family bigger and bigger. Okay, and anything that you want to say, please let me know in the comment section below. Yep, sir, if it made full rotational motion, I'm not sure. Oh, if it made full rotational motion, then it will come back to 0. Plus there is this ground which is stopping it, Selva Kumar, so it cannot complete the full rotational motion. Okay, Selva Kumar, I don't know what's there for dinner. I need to figure it out. All right. Thank you, Dinesh. Take care, Selva, Surinder. Yeah, thank you, Vikas. Bye bye, Chitra. Bye bye, Harita, Roshni, Strashti. Take care. Take care. Take care, Chandan. Have a great time. And yes, Surinder, there are lots of test series for JEE 2022. You can go check out. The one option is vPro. Second option is just go to the different tabs of Vedantu. You will see mock tests going on. There was one offer just few days back which just expired. I mean, there was a mock test series which was going on, and you could have given that and you could have won lots of discounts. Plus, you would have got report cards based on your performance. That happened just before Diwali. You missed that. But if something comes up, definitely I'll let you know. Okay. So there was free mock test series which was going on 2-3 weeks back. All right. So anyways, take care. Have a great time. I'll see you around again day after tomorrow. But tomorrow my 12th standard class will be there at 5:30. All right. Till then, take care. Stay safe. Have a great time. Hasta la vista.